Okay, let's talk about arc length. So, if we have a circle with radius r, we know, or you should remember from 8th grade math, that this circumference, the distance all the way around circumference, is 2 times pi times r. Now you may remember the formula pi times the diameter, which is perfectly valid, but we tend to know the radius a lot more often, and this one's a much more convenient. So circumference, distance all the way around is 2 pi r. What if we don't go all the way around? What if I only traverse some angle theta here? So I want this distance here that we might call s. So we call theta our central angle. S we call the arc length. And it's literally the length of this little arc of the circle right there. Well, first off, if theta is 360 degrees, if we go all the way around, then we already know what S is. If you go all the way around, S would just be the circumference. What if we went halfway around? What if, I don't know, maybe theta were 180 degrees? So we got some circle, and I go from here and rotate to here. I want this length there. Well, that's obviously half a circle. We get half the circumference. So, that should motivate to see that whatever fraction of the way we go around, we'll end up getting that fraction of their circumference. If I went 1/8 of the way around the circle, my arc length would be 1/8 of the circumference. So that motivates this proportion here. S over C, which of course is S over 2 pi r, will equal our central angle out of 360 degrees. The fraction of the angle you go around out of the entire way equals your arc length out of the entire length. Now we're going to learn a different formula later once we learn radians. Notice even it's in the title here. This is for degrees. So I'm going to specify here, I'm going to say theta measured in degrees. I put a little d there. Now, you might sometimes see people write this formula a little different. They might say multiply both sides of this equation by 2 to eliminate that 2. And you might also see S out of pi r, just eliminating that 2, is theta in degrees out of 180 degrees. And this is perfectly fine. If you would like to memorize that, you can. I don't memorize that because I literally think, okay, the fraction I've traversed out of the entire equals the angle I've traversed out of the entire way around. Okay, let's look at some examples. So here, you can read the question. I've got 10 units. Let's say instead of units, let's be specific and say we have feet. And I have a central angle of 215 degrees. So I'm starting here at, say, 0 degrees, and I'm rotating. Here would be 90 if I went to there. This would be 180 if I rotated halfway around. I want to go a little more than 180. So about here, I'm rotating this way. Theta is 215 degrees, and we know our radius is 10 feet. Then we could calculate our arc length, this big length up here. We know S divided by the entire circumference is the angle we actually went, measured in degrees, out of 360 degrees. So just filling in what we know the radius, I know the angle, S is who I'm after, s out of 2 times pi times r, 10, equals 215 degrees out of 360 degrees. Clean up the 5. Now, degrees are units. I can just cancel those degrees out. And I could clean up this left-hand side. 2 times pi times 10. I can just multiply the 2 and 10 and get s divided by 20 pi equals 215 out of 360. And now, if you handed this to me, oh, I don't need that degree anymore. I would go ahead and reduce this fraction. But we don't need to. We don't have to. I could. I'm trying to get s by itself. I want to get rid of this 20 pi. I could multiply both sides by 20 pi and get s is 20 pi times 215 out of 360. And what are my units here? Feet. And if I wanted to approximate that, if the question said round to 2 decimal places, I could just type that in my calculator. 20 times pi. To get pi, it's right there. I have to hit second. Times 215 divided by 360. There's my arc length, approximately 37.52 feet. If I rounded to 2 decimal places. Now, personally, I would rather, instead of getting an approximation, just clean up this fraction. So I would look and go, well, let's see, 20 goes into 360 18 times, because 2 goes into 36 18 times. So maybe it would be better to write this exact answer. Oh, but I think I can reduce again. No, 3 does not go in here. No, I don't think that will reduce any. And we could leave it like that. I could circle it. I got to put on my units, feet. Or again, if I wanted to, I could throw that in my calculator. 215 times pi divided by 18. Hey, look, we get exactly the same answer. So if the question asks for an exact answer, don't throw it in the calculator. If it asks you to round appropriately. Okay, let's look at another one. I can make this a little bigger here. So now we want to travel along the Earth, 5 degrees along the Earth. We've got the radius of the Earth. We've got our central angle. We can find our arc length. So let's quickly just draw our picture here. Anytime a picture is appropriate, you should always draw a picture. So I'm rotating 5 degrees, and my radius here is 3,960 miles. So our arc length is going to be measured in miles. Arc length is a length, and it always has the same units as the radius. Okay, so then s out of 2 times pi times r equals the central angle, 5 degrees, out of 360 degrees. The degrees cancel. That is a 5 there. And then I would just take all of this and multiply it up here. S will be 2 times pi times 3960 times 5, that 5, all divided by 360. And again, if we went around, we could just type that in our calculator. Order doesn't matter on top when we're multiplying. So I'll just do it in the order I wrote it there. 2 times pi times 3960 times 5, all divided by 360. 345.58 miles. Was it 345? Yeah, 0.58 miles. And don't forget your units there. Okay, that's a good place to stop.